this demonstration, I'm going to show you how smoke analysis works within PSpice Advanced Analysis. So within PSpice Advanced Analysis, there's 5 features, and in this one I'm going to talk specifically about the smoke feature, which is used to detect component stress. And with this tool, you can set up your limitations for your various components and then run simulations against those limitations and see how stressed your components got over the course of that simulation. So you can check things like voltage, current, power, and even temperature. Let's take a look at the tool and see how it works. So here's Capture, and this design is the RF amplifier available in the Capture sample directory in the tool. And if you want to run a simulation on this, you can just run it right away. So you can just hit run. That's going to run it, and you're going to get some results here. So I'm taking a look at some specific results here that I'll get into in a second. For smoke, what we want to do specifically is we want to say what are the limitations of our components, and then we want to run a simulation like I just did and see how far I've pushed my components. So to set your limitations for your components, the easiest place to start for passive components is to just use resistor parts or capacitor parts from the PSpice elements library. So in the PSpice_ELEM library, there's some parts here that are really good with smoke. So this inductor part, this resistor part, and the capacitor part up here are great parts to start off with. You're also going to want to place the variables part from this library as well. That's the equivalent of this block right up here that I'll show you in a second. Alright, once those parts are placed, you can then easily enter smoke limits for your components. So your resistors, your maximum rating is 1/4 watt right there, and that just ties right in with this resistor. It ties in by virtue of this property right here, power, Rmax. So it points to that variable, and everything's hooked up right away. So they're really easy to use as long as you're using those parts. Alright, so that's your passive components. For active components, you're going to go into the model editor. So in the model itself is where the active components are going to be modeled for smoke limitations. So to get there, just select the component, edit PSpice model, and that's going to bring up the PSpice model editor. So we'll take a look at the model editor right here, and in the smoke tab, here's the smoke tab that should be available for your part. If it's not, just go here to model, add smoke, and that'll add that smoke tab. In this tab, we're able to see all the limitations for our component for a variety of different measurements. So we have some current limitations. Maximum collector current is 50 milliamps. Maximum collector base voltage is 20 volts. Maximum collector emitter voltage is 12 volts, etc. You can read through those. I'm going to focus on the VCE, maximum collector emitter voltage, for this component. It's valid for peak, so the highest that this measurement gets is what it's valid for, and it's 12 volts. So that's the limitation for the collector emitter voltage for this transistor component. I'm going to close out of here. I don't need it anymore. Those are my limitations that have been specified. I can, if I want to, without using smoke, I can just go into my simulation results and measure this, which is what I've done right there. I've put a differential probe across the collector emitter, and I can take a look at the voltage that I'm seeing right here. This is what we saw before. So I can see that the peak of this is approximately 8.14 volts, a little bit above that, and I can set up a measurement to view that very specifically if I want to. So I can evaluate that measurement and see exactly what it is if I want to. That can get cumbersome if you're doing a lot of these measurements, which you're very likely to do in a regular size circuit, and that can get cumbersome and tough to do and tough to get correct. So a nicer way of doing this would be to run smoke instead. So after I've done this transient simulation, I've set up all my smoke limitations for all my components. I can then go to PSpice Advanced Analysis and to the smoke tool right here. That's going to invoke the Advanced Analysis tool set and the smoke option within that. And what it's showing me now is it's showing me the components that have been pushed the furthest with respect to their limits. So Q1 here is at the top. VCE is the parameter, voltage collector emitter. You can hover over that if you don't remember what that stands for. And average, peak, and RMS are all displayed. 12 volts is the maximum rated value. The measured value, there's 3 different measured values. One for peak, I guess the average and RMS are the same in this case. And the average and the RMS are also grayed out here in the percent max. That means they're not valid for that. As we remember, peak was the only one that's valid. So we can just right mouse button in this space and hit hide invalid values. And that's going to get rid of all those gray values. So now you can see a list that very quickly gives you information about how hard you're pushing all your components in your design. So you know if some of them are going to fail, if they're being pushed beyond their limitations, or if they're looking good. And in this case, most of them appear to be looking pretty good. I may want to, though, set some derating, and that means I want to design some safety into my design. So I want to make myself some space so that I'm not designing right to the limits of my components, but something off of that so they have a little bit of room to grow in case they're pushed a little bit further. So to do that, we can just go to derating, standard derating right here. You can also make your own derating files if you want to. I'm not going to cover that, but you can go into standard derating and just rerun the simulation. And that just takes half a second, and it gives us results now showing us with a derating value in here. So for Q1 VCE, that's the same parameter we're taking a look at, still rated at 12, still measured at 8.14, but now the derating is 6 because we're derating this 50%. So that means instead of allowing ourselves to design up to 12 volts, we're only going to allow ourselves to design up to 6. We're now exceeding that with the same measurement that we had from before, 8.14, by 36%. So this is failing. It's marking that for us in red, and now we need to take care of this. So what Smoke does for us is it brings these types of things to our attention so that we can solve these problems without having to hunt for them or find them later on when it's potentially too late. Thank you very much for watching. I hope you enjoyed this demonstration. Bye.